Okay, up next we have Lovedeep Gondara on using R Shiny for cancer surveillance lessons from the trenches.
Okay, hi everyone. I'm Lovedeep Gondara. I'm a research scientist at Provincial Health Services Authority, British Columbia, Vancouver. So before this position, I led the feasibility study, design, and development for the Shiny apps to be used as end-to-end dashboard system for cancer surveillance. And I was a little too lazy to memorize everything, so I got my little presenter notes here. Okay, let's see. Sorry, I'm trying to figure out.
So you got to use this,
This one.
and then I think this goes as PDF.
This scroll.
Yeah.
Perfect, thanks. Okay, so before we get into the Shiny or anything else, just a quick background that why do we need these dashboards for cancer surveillance? So first of all, it is really important not only for researchers to have access to the data for cancer statistics, but also for the public to see where the current state of healthcare is with respect to cancer care. So it doesn't only have to be like the number of cancer cases, but also cancer mortality, the treatment wait times, and how's everything going. So it's really important, especially in a publicly funded health system such as we have it in Canada. So it's our responsibility to make this information publicly available. So in addition to this, what we want to make sure is that not only the data is publicly available, but we also have to keep in mind our target audience. So our target audience in this case is not only the researchers that might know what the data is, but it's also general public, where we cannot just throw out scientific terms and just expect that everyone will understand what we are talking about. So we can't just put out tables and tables of data of like cancer incidence, mortality rates, age standardized rates, and just expect that everyone looking at those numbers will understand equally. So at BC Cancer, we have been doing cancer surveillance for at least 25 years, if not more. So from the time of our very first public cancer registry, that was in early 70s. So we have been publishing something periodically. But before we moved on to using our Shiny, we used to use PDF reports such as like this. So these were public facing, available for download on our website. This example specifically is for the referral rates in each health authority by cancer grouping. So this is probably one of the easiest reports to understand for general public, but even in this case, it will be without giving a proper context, it will be hard to understand that why the numbers are much higher for a certain type of cancer compared to another. So this again just emphasizes the need of having something more interactive with more information where we can easily provide some information that anyone looking at the report can equally understand what's going on. Oh, and another thing, this used to be our SAS era. So everything used to be done in SAS, the reporting, producing these PDF reports, and then they used to be uploaded. And this went on till about 2015. So entering 2016, I was able to convince my manager that we can probably do something better in R. So as a first step, we decided to go with just using R Markdown as our basis to create some sort of dashboards. So using our Markdown, we were able to pilot a couple of reports where not only we were able to provide interactivity by using Plotly, but we were also able to provide a couple selection buttons, as you can see on the top left, within this program, within Plotly, that will behave like someone is dealing with an interactive dashboard. And we were also able to provide links to download raw data. So this was our first step. And then moving from here, once our executives were convinced that this looks like a promising direction, from that point onwards, I tried pushing towards moving towards our Shiny. So then the question was that why do we need to move to our Shiny? Why not just stay with the markdown reports that we have? So the first thing is interactivity. Although our markdown reports are interactive enough, but they are not truly interactive. The reason being that our markdown works on a full static data table that's sitting in the back. So that's all it can access, and that's all it can manipulate to show whatever we want. Another thing was we wanted to make sure that our reports will react to user input, that the user input doesn't need to be something that's hard coded into the report, such as we have to do in our markdown. And the third thing was that we wanted to make sure that real-time data manipulation, modeling, and output would be possible. The reason being some of the cancer surveillance reports, they are quite complex, that are actually running statistical models in the background. An example would be using joint point analysis when we are looking at long-term cancer trends. So just to see how many of those breakpoints we have, how many times the cancer trend changed in the last 60 years. So those models are running live in the back end. So that was another motivation for us to move to something similar to our markdown. Oh, sorry, similar to our Shiny. The last one was the multidimensional nature of our Shiny. So this is a snapshot of our current dashboards that are all made using our Shiny. And by multidimensional, I mean that the users are able to slice and dice the data the way they want. They can select the type of plot they want. They can select the number of years that they want to look at. They can select any of the other reports that are on the top that they want to switch to. They can change their access titles, the way they want to download the plot, the way they want to download the data. So it is a full-fledged statistical dashboard. Almost we have gotten to a point that we can actually create the dashboards in a way that is point and click statistical analysis for the end user. So now for the roadmap, how did we get there? So the first thing after we moved on to the markdown reports were the discussions with our managers, with our executives, that what do we want? So what's the minimal viable product in this case? What kind of dashboards do we want? What kind of interactivity we want? And we had three main candidates. We already know which the winner is. But we did have candidates such as Tableau, the reason being the BC CDC. They are right now moving towards Shiny, but at that time they used to be big on Tableau. So all the public facing dashboards for disease surveillance from CDC used to be developed using Tableau. So that was one of the contenders. Then the second one we were trying to push was our Shiny. And the third one was Power BI. And the reason being that PHSA and BC Cancer, they had a full license to Power BI. So it essentially came as a free tool. So then our executives, we have to make a strong business case that why can't we use something that just comes as a free tool from Microsoft? Why do we need to move to our Shiny? So then we have to do all the comparison to show that what we can do in our Shiny is actually not possible to do in Power BI. And so for that, we got the go ahead, and then we have to justify. That one was actually the easiest part when we told them the cost of a Tableau license. They were like, okay, well, that's good. You see, you're saving a bunch of money. So then we ended up with our Shiny as the winner. And then again, that was probably the easier part to convince the executives for us to at least prototype some of the dashboards in our Shiny and show them how they will work. Putting them into production was a completely different thing. The reason being the data that we use for these dashboards is used to be patient level data. And due to the stringent privacy requirements, the only way we can create those dashboards is if the data does not leave premises. And we couldn't do that. The reason being our Shiny requires a Linux-based server, so Unix-based operating server. whereas our IT only supports Windows-based servers. So we were at crossroads there. So we went back and forth for quite a while, and our IT wouldn't budge. They wouldn't support a Linux-based server. So we ended up deciding on cutting on the data, the way we will upload the data. So we ended up using aggregated data instead of individual level data. So aggregating the data at the minimal level that we can use to create those dashboards. So with that, we were able to get okay from our privacy commissioner. And with that, we moved on to prototyping some of our apps on shinyapps.io. And that's still where they are being hosted. So yeah, and that covers the data privacy and the confidentiality issues as well. Another one of the major obstacles was at the time when we were prototyping them, I was one of the only R users in the unit, and not only we have to convince the rest of the statisticians that we need to move to R, that they need to learn R, but we had to teach them to be Shiny developers because we need backup. We cannot rely on one person in the unit doing all the Shiny development. We need support when that person is away. So that was another challenge, just a huge learning curve for Shiny. But as most of us here are from technical background, and most of us are here are self-taught, are programmers. So once we showed them what's possible using Shiny and motivated them, it was really easy for them to just go and learn at their own pace. And now all the statisticians in the unit, they are all expert Shiny developers. Another major challenge was that we didn't only wanted a prototypical Shiny application that is sitting in isolation. We wanted to give a nice user experience because we knew that we couldn't host the Shiny apps on our own server, that we are putting them on shinyapps.io. So we didn't want it to have like 20 dashboards where user goes on one dashboard. Now they want to navigate to another report. So for that, they will have to come back again to our homepage, select another report, again, go back to shinyapps.io. That would have completely broken the user experience and would have just defeated the purpose. So we did a bunch of investigations, spent a little bit of time. We came up with some custom JavaScript and CSS where we were able to create kind of a dynamic header, which now, so the header that you see here is actually sits on GitHub. So we only need to edit it once whenever we are adding any new dashboard. So we just need to edit this header at that central GitHub location, and it gets picked up by each app. So now each app has this uniform header. So you don't need to now navigate back to our BC Cancer's homepage. So once you're in this dashboard, you actually stay within the dashboard. And we have close to 20, if not more, different Shiny dashboards each. And from each of the dashboard, you can go to any other dashboard that you want. So this is what we wanted to achieve, and we were able to do that. And lastly, so there are two different approaches of creating Shiny apps. So the standard approach is where we keep a single code file for the server and the UI file. So that approach is really good for quickly prototyping applications. It's very easy to debug because it's one code file. You can just go through it and see where you're getting an error. And the downside of that, though, is that it's hard to version control, and it's a little bit harder to document. The other important approach, I would say, the one that I personally lean towards is the modular approach using something like Golem. The reason being, if we are using Golem, we can actually develop a Shiny app in the same way as we develop an R package. So if I'm pretty sure most of you have some experience developing R packages or dealing with them. So it's very, very familiar. It creates a Shiny app as a bare bone app in the same structure, same file structure, same documentation as it is an R package. And then we can just go from there and build on top of that. And they are really easy to share. To give you a quick example, once we had these dashboards up and running, we had a request from Statistics Canada. They wanted to take our code and they wanted to implement these dashboards internally on their own cancer data for their own surveillance. And we also had requests from other jurisdictions within Canada that wanted to use similar code to us. So using Golem in that way, we were easy. It was really easy for us to share the apps in a modular way. We will just put the whole package on GitHub, and then we will just send them an email. Okay, there is the package with the complete documentation. They will go and get it, install it as an R package, play around with it, and then go from there. And for the interest of time, again, it was a team effort. So this is the BC Cancer R Shiny team. These are all statisticians that are now expert Shiny developers. So we got Colleen, Kim, Jeremy, Eric, Yelling, and Rian. And that's it. So this is my email, and that's my Twitter handle if you have any questions later on. So thank you very much.